Welcome to another episode of Terry's Notes, and today we are going to be looking at some organic chemistry questions. In this first question, we have compound A with formula C3H6. We have compound B with formula C3H8, and they are hydrocarbons, meaning that they have carbon and hydrogen only. Now the first part asks for the fully displayed structures and the names of both compounds. Now, we know that the general formula for an alkane is CnH2n plus 2, and the general formula for an alkene is CnH2n. Therefore, if we have 3 carbon atoms, the formula for that alkane will be C3H, 3 2s are 6 and 2 8, so it'll be C3H8, and if it's an alkene, it'll be C3H6. So therefore, C3H8 is really compound B, so therefore compound B is an alkane, and compound A is an alkene. Now we want to draw the displayed structures, so therefore A is an alkene, so we draw 3 carbon atoms, and we need to put in a double bond because it is an alkene. Now, you need to be very careful when drawing displayed structures. You need to remember that around each carbon atom there are 4 bonds. So we have 1, 2, 3, 4. For this carbon we have 1, 2, 3, 4. And for this carbon we have 1, 2, 3, 4. And the name of this, we have 3 carbon atoms, so therefore this is called propene. And let's draw the structure for B. We said B is an alkane. It has 3 carbon atoms, so therefore this will be the displayed formula for B. Now the question says that one of these compounds reacts with bromine dissolved in trichloroethane. When you see this reagent, especially bromine, we are looking for a reaction with an alkene. So therefore A is the compound that is going to react in this case. And what is the observation? When they ask you for an observation, they ask you what are you seeing, what are you smelling, what are you hearing. So in this case, we're going to have a color change. The bromine will change from brown to colorless, right? And the type of reaction in this case is an addition reaction. And the question asks for an equation, so we start off with C3H6 plus Br2, and this gives us C3H6 Br2. And the last part asks for the fully displayed structure of the product. So we are talking about this product here. So it's an addition reaction, and the displayed formula is we have 1 bromine here, 1 bromine here. So this is the structure they are looking for. The bromine, the Br2, adds across the double bond. Right, so the double bond becomes a single bond, and the bromine is attached to a bromine atom is attached to each of the carbon atoms. Okay, in this next question we have 3 compounds, X, Y, and Z. And the question asks, what are the names of the homologous series to which each of the 3 belongs? Now, compound X has an OH group attached to a carbon atom, so therefore this is an alcohol. In the case of compound Y, the functional group present here is this group, which is the ester group. And in case of compound C, we have this group here, which is the carboxylic acid group. Alright, so write the names of the homologous series. So compound X is an alcohol, compound Y is an ester, and compound Z is a carboxylic acid. State which 2 of these compounds are soluble in water and give reasons for your choice. Now, X is an alcohol, and alcohols tend to dissolve in water. And the reason for that is the presence of the OH group. The OH group is able to form strong bonds with water molecules. If you will recall, a water molecule looks like this. So this is water, and water is a polar solvent. So there's a delta plus charge on the hydrogen atoms and a delta negative charge on the oxygen atom. Oxygen is more electronegative than hydrogen, and therefore the electrons in this bond are shifted towards the oxygen atom, and this is what makes the water molecule polar. So in the case of the alcohol, the OH group is able to form a strong bond with the water molecule, and therefore the alcohol will be soluble in water. The other group that will dissolve in water is the carboxylic acid, and that is also because of this OH group that is present here. In this question we have 4 compounds, and compound A is an alcohol because we have the OH group present. So A is an alcohol. In case of compound B, we have the COOH group, which is the carboxylic acid group. So it's a carbox. In this compound we have an OH group present, so therefore this is also an alcohol. And compound D has this functional group here. Now, first question asks, state 2 compounds that belong to the same homologous series. So we know that compound A is an alcohol and compound C is an alcohol, so they belong to the same homologous series. State the homologous series to which they belong and give the general formula. So we said that they belong to the alcohol functional series, alcohol homologous series, and the general formula is CnH2n plus 1 OH. And I said draw the structural isomers of compound C and state their names. So this is compound C here. Now they want 2 structural isomers, so all you really need to do is to move around the OH group. So we have 1, 2, 3, 4, 5 carbon atoms, so you can put an OH somewhere in the middle. Now remember, a structural isomer, they have the same molecular formula but different structural formula. So all I've done in this question here is move the OH group. So this is one isomer, and we can draw another one. And what we can do is probably shift one of the carbon atoms. So this structure here will represent another isomer. Okay. And then this next question, we have propene, which is represented by this molecule or this displayed formula. It said draw the structure of the polymer formed when propene from propene. Use 3 units of the monomer to demonstrate your answer. Now, this type of reaction is an addition polymerization, and this occurs because of the presence of the double bond. And the key thing to remember here is that when the polymer is formed, the double bond disappears. It turns into a single bond. So all you have to do is to draw the exact same molecule, but instead of drawing a double bond, you draw a single bond. And they want 3 units of the monomer. What I've drawn here is 1 unit, so I need to draw 2 more. So this represents an addition polymer. So this is actually polypropene, and we have drawn 3 repeat units. We have 1, we have this one, we have 2, and we have the third one here. The next part asks, outline a chemical test that can be used to distinguish between propene and its polymer. So this is the polymer here, which is polypropene. And this is propene. Now remember, the key difference here is that we have a double bond present in propene and there are no double bond present in polypropene. So therefore a chemical test that we can do is to add bromine in tetrachloromethane, CCl4, and if we add the bromine in tetrachloromethane to propene, what we will get is that the bromine will go from brown to colorless, because we're going to have an addition reaction taking place. So the color change or the observation is brown to colorless, and we will only get this reaction with propene and not with the polymer polypropene. In this next question, we have an amino acid. We have 3 amino propanoic acid. In an amino acid, we always have 1 acid group and we have an amine group present in the same molecule. Now the question asks, what type of polymerization would 3 amino propanoic acid undergo? Now we are not seeing a double bond present here, so therefore it has to be a condensation polymerization. And the question asks, so the first part, type of polymerization, so it is condensation, and state the general name of the type of polymer formed from 3 amino propanoic acid. Now this is an amino acid. When an amino acid polymerizes with other amino acids, it forms protein. Alright, and remember, protein is a polyamide, and it is a polyamide because it has the amide group present, which looks like this. So this is the amide group. So we have, in this question, we have but1-ene and but2-ene as structural isomers. Both of them have molecular formula C4H8. And the first part asks, what is meant by the term structural isomers? Well, structural isomers are compounds that have the same molecular formula. In this case, both of them has a formula C4H8, but they have different structural formula. Second part asks, draw the structures of but1-ene and but2-ene. So in the case of but1-ene, now but means that we have 4 carbon atoms present, and the fact that we have this one here, it means that the double bond is really on the first carbon atom. So we're going to draw but1-ene. Always remember, double check the amount of carbon atoms, double check the amount of bonds around each carbon atom. So in this case, this will be but1-ene, and but2-ene, the 2 means that the double bond is on the second carbon atom. So but2-ene will look like this. So this is but1-ene, and this is but2-ene. The next part, draw another possible structural isomer and state its name. Now, if we notice, in the first structure that we have here, we have the double bond on the first carbon atom, and then in the second one we moved it to the second carbon atom. So now what we can do is put a carbon here, and another carbon here, and this would represent another structural isomer. Now, in order to name this compound, we usually find the longest carbon chain and we number them. So it'll be 1, 2, 3 carbon atoms. So we know that it'll be propene, and this group here is called the methyl group. So therefore the name of this compound will be 2-methyl propene. So the last part of the question asks, state one physical property of C4H8. Now we know that in any homologous series the physical property changes as we move down the homologous series. So we may start off with a gas, then move to a liquid, and then to a solid. Now C4H8 is butene, and most likely it will be a gas. Crude oil can be separated into different compounds by a process called fractional distillation. State the principle upon which fractional distillation is based. Now, crude oil is a mixture of different compounds, and each compound has a different boiling point. And it is because of this that we can use fractional distillation to separate the different compounds. So for part B, name the lightest fraction. The lightest fraction will be refinery gas, and it is used for cooking. So that is for part B. And state the name of the heaviest fraction and state its use. The heaviest fraction from fractional distillation is bitumen, and this is used for paving roads. Okay, in this question we have this compound, and the question asks, draw the structure of the product formed when the compound reacts with sodium and bromine. Now, whenever we are given a question like this, the first thing we need to do is to identify the functional groups present, because this is what determines how the molecule is going to react. So we have this group here, the OH group, which is an alcohol, and we see that we have a double bond. So therefore this is also an alkene group present. So the sodium, we know that the sodium reacts with the OH group, so they want the structure drawn when it reacts with sodium. So therefore it will look like this. We have O, the H is replaced with the sodium, and everything else remains the same. So this is the answer for part 1. For part 2, the reaction with bromine. Now the bromine is not going to react with the OH group. It is going to react with the alkene group. So we are going to leave the OH group as is. And what is going to happen is that the double bond is going to turn into a single bond. Sorry, this is Br. And this reaction is an addition reaction. So the bromine just adds itself across the double bond. In part B now, the compound above undergoes a polymerization reaction. State the type of polymerization reaction that occurs. Now remember, we have two types of polymerization. We have addition polymerization and condensation polymerization. As soon as we see we have a double bond, we expect it to undergo an addition reaction. And so the first part here, state the type of reaction, type of polymerization. So it's an addition polymerization. So it's addition. And draw a diagram of the polymer showing 2 repeat units. So remember, in an addition polymerization, the double bond is all that disappears. So we're gonna draw OH, so this is just 1 repeat unit. To draw 2 repeat units, it'll look like this. So notice it is not a difficult question, because all I have done is redrawn this, and instead of putting a double bond, I've put a single bond. Okay, we have a diagram of a polyamide, and it's a polyamide because we have the amide linkage. Some students get confused with this because the amide linkage is sometimes drawn like this, or it's sometimes drawn like this, but it's the same linkage present, the amide linkage. State the type of polymerization undergone to produce this polyamide. As soon as we see a polyamide, we know that it is a condensation polymerization. So it's condensation polymerization. And this particular polyamide is naturally occurring. Give an example of a naturally occurring polyamide. A naturally occurring polyamide is a protein, and this polyamide can undergo acid hydrolysis in a test tube and enzyme hydrolysis in the human body. The reaction conditions are different in both cases. State the difference in the reaction conditions. Now, in the lab, a protein can be hydrolyzed. It can be hydrolyzed by boiling the protein with dilute sulfuric acid or dilute hydrochloric acid. In the case of enzyme hydrolysis in the human body, the enzyme reacts with the protein and breaks it down slowly. So the conditions are not as extreme as in the lab because you have to boil with an acid. Whereas in the body, enzymes react on the protein. So therefore the reaction conditions are different in both cases. And the last part asks to draw the monomer of this polyamide. Now, to draw the monomer, if you look, you will realize that the molecule that is repeating is this. So polyamide, now this block here is just a symbol. It's used as a simplification of the molecule, so don't get confused with it. It's just a box. And whenever we want to determine the monomer, we need to remember that what makes an amide linkage is the presence of an amine group and an acid group. So this would be the monomer for this polyamide. It's a polyamide, therefore we're going to have an amine group present and we're going to have an acid group present. In this question, we have a question that asks, what is a hydrocarbon? A hydrocarbon is a compound that contains carbon and hydrogen only. Part 2 asks, what is a homologous series? A homologous series is a group of organic compounds that have the same general formula and they have similar chemical properties. The next part, what is a functional group? A functional group is an atom or group of atoms that determines the chemical properties of a homologous series or the chemical properties of a compound. State 4 properties of a homologous series, and the first property is that they have the same general formula. The second thing is that they differ from each other by CH2. We also know that the physical properties vary as the number of carbon atoms increases, and they all have the same chemical properties because they have the same functional group present. Now part C asks, state the functional group present in ethanol. Now ethanol, just by looking at the name, we expect it to be an alcohol. So therefore it belongs to the alcohol group. Ethanol can undergo various reactions to produce the following functional groups. Now the first part asks, state the name of each functional group. Now we see a carbon to carbon double bond, so we know this is an alkene. In this case, this functional group is a carboxylic acid. And this group here is the ester group. Now, so the first part asks to state the functional groups present. So the first one we said was an alkene, the second one is a carboxylic acid, and the third one is an ester. State the reagents and conditions used to produce each functional group, starting with ethanol. So we are starting with an alcohol, and we want to get an alkene. So if we go from ethanol to an alkene, the alkene in this case will be ethene, and the reaction conditions for this is we have to heat with concentrated sulfuric acid at a temperature of 170 degrees C. So it's 170 degrees C, and it's conc H2SO4. So in the exam you need to give the temperature and you need to give the reagent, and this type of reaction is a dehydration reaction. In the second case, they want to produce a carboxylic acid. So if we start off with ethanol, and we want to produce, in this case we go into an acid, so it'll be ethanoic acid. And the reaction conditions in this case is that we have to heat with acidified potassium dichromate 6. So you heat with H plus K2 Cr2O7, or we can also heat with acidified potassium manganate 7, KMnO4. So you can give, so we need to heat, and we need to heat with an oxidizing agent. So we have acidified potassium dichromate 6 or acidified potassium manganate 7. And this reaction is an oxidation reaction. In the case of the potassium dichromate 6, we have a color change that takes place. We go from orange to green. And in the case of potassium manganate 7, we go from purple to colorless. And the last one now, we want to get the ester group, starting with ethanol. So we go in from ethanol to ester. When we have an alcohol and we want to produce an ester, we need to take the alcohol and react it with a carboxylic acid, and we use concentrated sulfuric acid as a catalyst for the reaction. So we need to react with an alkanoic acid, and the conditions here is we're going to heat under reflux. So alkanoic acid, we're going to heat under reflux, and we're going to have conc H2SO4 acting as a catalyst for the reaction. And the last part of the question asks to draw the structural formula of the organic product formed in each case. So in the case of ethene will look like this. In the case of ethanoic acid, it will be key thing to remember is we have 2 carbon atoms here because it's ETH, so therefore we have 2 carbon atoms. And then the last one, the ester in this case, let's say we use ethanoic acid, then the ester will look like this. So this would represent the ester molecule. Okay, in this next question we have compound E, and we have different reaction taking place. So whenever you're given a question like this, you need to look at the question properly to see all the reactions that are taking place. So we have a compound E here, but if you look at the diagram, you realize if you start off with glucose and yeast, we're going to get a compound E. Based on our organic chemistry knowledge, we know that if we take glucose and yeast, we are actually performing fermentation, and we expect an alcohol to be produced. So compound E is most likely an alcohol. We can check again, because in reaction 1 we can move from an alcohol to an alkene. That is true. And in the case of reaction 3, if we burn the alcohol in air, we get compound F and water. Okay, so state the reagents and conditions for reaction 1. So we know that E has to be an alcohol. And in this case, it has to be ethanol. So the the reagents and conditions for reaction 1. So we're moving from ethanol to, in this case, this is ethene. And when you move from ethanol to ethene, that is a dehydration reaction. So the reagents and conditions will be 1 heat at 170 degrees C with conc H2SO4, because this is a dehydration reaction. So the reagent is concentrated sulfuric acid, and the conditions is heat at 170 degrees C. Part B, state the name of the reaction occurring in reaction 2. As I indicated earlier, that is fermentation. We have to draw the structure E. We know that E is an alcohol, and this will be compound E. It has 2 carbon atoms and an OH group present. So this is ethanol. And write a balance equation for reaction 3. Now ethanol is CH3 CH2 OH, and you're burning in air, so therefore you're going to react with oxygen, and you are going to produce CO2, carbon dioxide, and water. And if you have to balance this equation, you will have to put a 2 here, 2 in front the carbon dioxide, and a 2 in front the water. When E reacts with this structure here, now this is a carboxylic acid, right? And in this case it is meat eat prop, it is propanoic acid. And we know it's propanoic acid because it has 3 carbon atoms present. So you're going to react this compound with the alcohol, so you're going to produce an ester. So what you will do is draw the propanoic part first, so I've drawn the ester linkage. So the first part of the structure, this part here, represents the propanoic acid part, and the second part represents the alcohol part. And it said name the organic compound form and state the class of compounds to which it belongs. So we already said that it belongs to the ester class of compounds. And the name, when you are naming these compounds, we start off with the alcohol part first. So it'll be ethyl, and the acid was propanoic acid, so it is ethyl propanoate.